This is a problem set in Regents questions on projectile motion. And the first problem starts with a scenario: projectile is launched at a horizontal speed. So I'm going to draw a picture of it. It looks like the speed this way is 20 meters per second. And it's from the top of a cliff. It strikes a level surface below 3 seconds later. So the time in the y-axis is 3 seconds. Time in the x-axis, also 3 seconds. Projectile B is launched horizontally from the same location at a speed of 30 meters per second. How much time does it take for projectile B to reach the level surface? Well, it's got to fall the same distance as projectile A, so the answer will be 3 seconds. Approximately how high is the cliff? We want to know the distance for the cliff for variable y. And we know it takes that much time to fall. Its horizontal velocity initial is 0. So, and it's going to do that under the influence of gravity. So we know the distance, y, is equal to VIT plus 1/2 GT squared. VI is 0, so it's 1/2 GT squared. 3 seconds squared is 9. 9 times, let's say 10, is 90. Half of that is about 45. Question 3. A projectile is fired from a gun near the surface of the Earth. The initial velocity of the projectile has a vertical component. So an upward component of 98 meters per second and a horizontal component of 49 meters per second. How long will it take the projectile to reach the highest point in its path? So we only care about the y, or the vertical component. So we've got an initial velocity of 98. The highest point, its velocity final, will be 0. Change in velocity will be 98. It'll change its velocity because of gravity, which is 9.8. And so if acceleration is change in velocity divided by time, then time is change in velocity divided by acceleration. So 98 divided by 9.8 gives it about 10 seconds to reach the highest point in its path. Question 4. A projectile is launched with an initial velocity of 200 meters per second at an angle of 30 degrees. What's the magnitude of the vertical component, or the upward component, of velocity in the y-axis? If you look at your formula sheet, you'll find that any vector's y component is equal to the vector times the sine of the angle. So we're looking at 200 times the sine of 30, and that would be choice B. Question 5. A ball is thrown horizontally with an initial velocity of 20 meters per second for the top of a tower, and the tower is 60 meters high. What is the horizontal velocity of the ball just before it reaches the ground? Well, in a situation like this, the horizontal velocity doesn't change. Regents Physics, we don't take into account air friction, so there's no other factor that could slow it down. So if it starts at 20, it's going to end at 20 horizontally. And what's the initial vertical velocity, or the downward velocity, of the ball shown in the diagram? Well, the whole basis is that its initial velocity in the vertical direction is 0. What is the approximate total time required for the ball in the diagram to reach the ground? Okay, well, it's got to fall a distance of 60 meters. It's going to do so under the influence of gravity, and its initial velocity downwards is 0, and we're looking for time. So we know distance is equal to VIT plus 1/2 GT squared. That's why VI downward is 0. So distance is 1/2 GT squared. 2 times distance divided by G. Take the square root of it, and that gives you the time. So let's see, 2 times 60 is 120. Let's say divided by 10. It's going to be 12, so it's the square root of 12. And so square root of 3 is 9, or 3 squared is 9, so let's say it's 3.5. You've got a fancy calculator, but I'm sure you'll find the same answer. Question 8 involves a soccer player we're told in the text as well as the diagram, initial velocity of 8.5 meters per second at 35 degrees. Its vertical component is 4.9 meters per second. Its horizontal component is an unknown. It's going to be less than 8.5, and 35 degrees has got to be greater than 4.9. Given the diagram, the horizontal component of the ball's initial velocity is, well, if you look at your formula sheet, you find any vector's x component is equal to that vector times the cosine of the angle. Well, I'm going to look at the answers. I find 13. It's got to be less than 8.5. I've got 4.9 and 3.6. Both of those are excluded because that's the y component, so it's got to be greater than that. So I'm guessing it's going to be 7. Of course, you got a fancy calculator. Type in 8.5 times the cosine of 35 degrees, and you'll have your answer. Maximum height reached by the ball in the given diagram is approximately. Well, the initial velocity in the y-axis is 4.9 meters per second. The final velocity is 0. So its total change in velocity is going to be 4.9. And I know the distance is equal to VIT plus 1/2 GT squared. In this case, it would be minus 1/2 GT squared because it's going in opposite directions. But I also know velocity final squared equals velocity initial squared plus 2AD. So I think that equation will give it to me. Velocity final is 0. This is negative, so velocity initial squared is 2AD. So velocity initial squared divided by 2g will give me my distance. Your fancy calculator will give you that answer, and I'm coming up with D as mine. Question 10, a vector makes an angle theta with the horizontal. The horizontal and vertical components of the vector will be equal in magnitude if angle theta is, well, you can do some fancy math, but you know it's not 30, you know it's not 90. 60 is just the opposite of 30. So if it was 30, you'd have these two components, and 60, you'd have them just simply reversed. The answer's got to be 45 degrees. Question 11. A ball is thrown at an angle of 38 degrees to the horizontal. 38 degrees. What happens to the magnitude of the ball's vertical acceleration during the total time interval that the ball is in the air? Well, let's stop and think. What causes it to accelerate up and down? Well, that's going to be g. Once it leaves your hand, it's not accelerating. It's just under the influence of g, the definition of a projectile. And so g is going to be the same for the entire trip. Question 12. A red ball and green ball are simultaneously thrown horizontally for the same height. So they come in from the same height. The red ball is 40 meters per second. The green ball is 20 meters per second. Compared to the time it takes the red ball to reach the ground, the time it takes the green ball. So all we care about is this. We're looking for time. Well, the initial velocity downwards is 0 for both of them. The distance is the same for both of them. The acceleration due to gravity is going to be the same for both of them. Time is going to be the square root of 2 times whatever that distance is divided by g. And so the time is going to be the same for both of them. Now the one that's going 40, the red ball, will go further away, but that's not the question. Just simply asking for the time it takes to reach the ground. Okay, question 13. An archer uses a bow to fire 2 similar arrows with the same string force, which indicates the initial velocity should be the same for both of them. One arrow is fired at 60 degrees, and one arrow is fired at 45. Compared to the arrow fired at 60, so we're asked to think about the one fired at 60, and 45 will be. Well, we know, let's talk about range. We know that 45 degrees gives you maximum range. So we want to find an answer that says more range. Longer horizontal range, okay, A could work. Shorter horizontal range, B won't work. Longer horizontal range, C could work. shorter horizontal range D can't work. So it's A or C. So the 45 degree will have shorter flight time or longer flight time. Well, shooting it straight up would give you the most flight time with the smallest range. And so 45 is less than 60, so it'll be shorter flight time. And so choice A is the correct one because it includes both variables that we know to be true. And finally, question 14. A golf ball is propelled with an initial velocity of 60 meters per second at an angle of 37 degrees above the horizontal. The horizontal component of the golf ball's initial velocity is, well, the velocity's got to be, velocity in the x will be the velocity. It'll be the velocity times the cosine of the angle. Make sure I'm in degree mode, and I say the 37 degrees. Hit the cosine, and I multiply that times 60. And I'm coming up with 47. Stupid pencil. And 48's the one you're going to pick. All right. Hope that helps. Bye.